Today's lesson is on solving two-step inequalities. As usual, there is a math video guide to go along with the problems that we do today. So if you haven't printed that yet, go ahead and pause the video, print that, and then come back and work out these problems with me. Now, we've already done a lesson on solving one-step inequalities. Two-step inequalities aren't that much different. Mainly, there's going to be two steps in actually finding the solution instead of just one. Remember, the key thing from solving one-step inequalities, the only difference from inequalities to equations is the fact that whenever you multiply or divide by a negative number, you must flip the inequality sign. That was the one key difference. Other than that, the steps are the same. So let's go ahead and take a look at problem number 1. Our inequality is 7 is greater than 6 plus n over 10. I'm going to draw my line through the inequality sign, and I want to get my variable, my letter, by itself. All right, the 6 and the 10 are keeping n from being by itself. Now you need to remember from solving equations that addition and subtraction always gets canceled first. We talked about how it's the opposite of the order of operations. So adding and subtracting must be canceled first, and then multiplying and dividing. So if I take a look, the 6 is being added to the n, whereas the n is being divided by the 10, which means the 6 needs to be canceled first. So to cancel out a positive 6, I'm just going to subtract 6 on both sides. So 7 minus 6 is 1. Keep your inequality. Because I didn't do any multiplication or division, there's no way I would have to flip the sign. Remember, adding and subtracting, you'll always keep the sign the same. These 6's will cancel, and then my n over 10 just comes down. So that's step 1. Step 2 is I need to get rid of this 10. Now, anytime they write a fraction, remember that means division. So this is n divided by 10. So the opposite of divide is multiply. So I'm going to multiply both sides by 10. On the left-hand side, 10 times 1 is just 10. Keep your inequality sign. And then over here, my 10's cancel, and I have n. Now, the reason we keep the inequality sign the way it is because I multiplied by a positive number. Remember, you only flip the sign if you multiply by a negative or divide by a negative, okay? There's no negatives in this part of the problem. I don't have to worry about flipping. However, we like to have our letter on the left-hand side, okay? So this tells me that 10 is bigger than n. But I want n first and 10 second. So if the 10 is bigger than the n, that means n must be smaller than 10. So I need to change this to a less than sign. Again, it's open towards the 10, so it needs to be open towards the 10 when you rewrite it. So your inequality is going to be n is smaller than 10. And if you want to check this, we could try 0. 0 is smaller than 10. If I put 0 in my inequality, and just kind of think it through in my head, 0 divided by 10 is just 0. 6 plus 0 is just 6, and 7 is bigger than 6, so I'm okay. This is the correct inequality. Problem number 2, we have 70 is less than 5x plus 5. Again, the steps are just the same as when you're solving an equation. All right, the only difference is if you multiply or divide by a negative, you flip the inequality sign. So, 5 and 5. I need to cancel them both out, but which one should I cancel first? This 5 is being multiplied to the x. This one's being added. So I need to cancel out addition and subtraction first, so I'm going to cancel out that plus 5. The opposite of adding 5 would be to subtract 5. So I'm going to subtract 5 on both sides. 70 minus 5 is 65. My inequality sign stays the same, and I have 5x here. These 5's cancel. 5 minus 5 is 0. At this point, I need to cancel out this 5. This is 5 times x, so the opposite of multiplication is division. So I need to divide both sides by 5. Here and here. 65 divided by 5 is 13. These 5's cancel and I'm left with x. Now, the inequality sign, to flip or not to flip? Remember, only when you multiply or divide by a negative number do you need to flip that inequality sign. Well, I did divide, but I divided by a positive number. So I'm going to leave this as less than. So 13 is less than x, but when I write it, I want my letter first. So x is going to come first, 13 will come at the end. My inequality is eating the x, it's open towards the x. We talked about thinking of it as a crocodile, those are the teeth. It's going to eat whatever's bigger. So down here, it's still going to eat whatever's bigger. So it needs to be open towards the x. So x is bigger than 13. Okay? So this would be my inequality if I want to check it. Thinking of a number bigger than 13 that's easy to work with, I would probably pick 20 because 20 is bigger than 13. So if I put 20 in here, 5 times 20 is 100, and 100 plus 5 is 105. 70 is less than 105 is a true statement, so this inequality is fine. Okay, my sign is correct. For problem number 3, our inequality is negative 5k minus 3 is greater than or equal to 52. So I'm going to draw my line through the inequality sign. I need to get rid of the negative 5 and the minus 3. Always get rid of the addition and subtraction first. So the negative 5 is being multiplied to the k, so I'm going to leave that alone. I'm going to get rid of the minus 3 first. The opposite of minus 3 is plus 3. So I'm going to add 3 on both sides. My 3's cancel. Negative 5k comes down. So does our inequality. Remember, only flip the inequality when you multiply or divide by a negative. And I added 3, so no multiplication, no division. 52 plus 3 is 55. At this point, I now need to get rid of the negative 5. So to cancel out the negative 5, this is negative 5 times k. The opposite would be to divide by k, to divide by negative 5, excuse me. So I must divide both sides by negative 5. My k comes down, the negative 5's cancel. 55 divided by negative 5 is negative 11. Now, to flip or not to flip, okay, you must look at this step right here. Both sides were being divided by a negative 5. So because I have that negative 5 on both sides of my inequality, that's when I flip it, because I was dividing by a negative amount. So instead of greater than or equal to, it becomes less than or equal to. So this is my answer. K is less than or equal to negative 11. And from there, I just pick a number that's smaller than negative 11 to try it out. So I'm going to go with negative 12. Negative 12 is smaller than or equal to negative 11. So if I plug that in here, negative 5 times negative 12 is positive 60, and 60 minus 3 is 57. 57 is greater than or equal to 52. That works out, so my inequality is good. I flipped the sign correctly. For problem number 4, we have b over 18 minus 4 is less than negative 5. Draw my line through the inequality sign. I need to get b by itself. Now, b is being divided by the 18, and the 4 is being subtracted. So, I need to cancel the 4 first. Always cancel out the addition or subtraction first. So to get rid of the minus 4, I'm going to add 4 on both sides of the inequality. So add 4 here and here. Minus 4 and plus 4 cancel. I have b over 18 is less than negative 5 plus 4 is negative 1. Almost finished, just need to get rid of that 18 now. All right, this is b divided by 18, so the opposite of divide is multiply. So I'm going to multiply both sides by 18. So my 18's cancel. I get b, and negative 1 times 18 is negative 18. And now to determine if I'm supposed to flip or not to flip. I multiplied both sides by a positive amount. Now true, this side has a negative, but this one doesn't. They both have the positive 18 on both sides. So that means my inequality stays the same. It's going to remain less than because I did not multiply both sides by a negative amount. I multiplied them both by a positive. So B is less than negative 18 would be my answer. To check this, because I'm going to divide by 18, I'm going to go ahead and say, okay, a number that's smaller than negative 18, I'm going to use negative 36, just because when I divide it, it'll actually come out nice. So negative 36 divided by 18 is negative 2. And negative 2 minus 4 is negative 6. Negative 6 is smaller than negative 5, so my inequality is correct. At this time, go ahead and pause the video, work out problems 5 and 6, and then come back to the video and check your work with mine. For problem number 5, the inequality was 10 minus 6x is greater than or equal to negative 38. I moved the 10 first. The 6 is being multiplied to the x. The 10 is separated from the x by a subtraction sign, so that 10 needs to be canceled first. So I subtracted 10 on both sides. Negative 6x is greater than or equal to negative 48 was my next step. From there, I need to cancel out the negative 6x, and because that's multiplication, I did the opposite, which is division. I divided both sides by negative 6. So that left me with x. I flipped the inequality sign because I divided both sides by a negative. So it became less than or equal to 8. If you wanted to check this answer, you could use 0 for x because 0 is less than or equal to 8. If I put 0 in for x, negative 6 times 0 is just 0, and 10 minus 0 is 10. 10 is greater than or equal to negative 38, so my inequality works. For problem number 6, we had negative 3 is less than negative 1 plus m over 2. Cancel out that negative 1 first, okay? Add 1 to both sides, so I got negative 2. I kept my inequality the same because I didn't multiply or divide by a negative. And then I have m over 2 over here. From there, to cancel out dividing by 2, I multiplied by 2 on both sides. 2 times negative 2 is negative 4. And over here, my 2's canceled, so I'm left with m. I did not flip the inequality sign because I multiplied both sides by that positive 2. Okay, there was no negative on the right-hand side, so I don't flip the sign. However, I did rewrite my inequality with m first. Okay, and because it was eating the m, I made sure it was eating the m down here as well. So m is greater than negative 4. If we want to check this, we can use 0 because 0 is greater than negative 4. 0 divided by 2 is just 0. Negative 1 plus 0 is just negative 1. And negative 3 is less than negative 1. So my inequality works. And that's the end of our lesson on two-step inequalities.